This one is from 206 to 275 bar. This one is from 344 to 413 bar. And you'll see the reason we use this when I set it up. So this spring is in here. So if you wanted a different spring, you would just take this off, put that spring in, and then put a different sticker on it. I really think it matters. This nut goes here. That's a switch. This is a little short. I would maybe make one of these out of teak.
Teak.
Yeah. All right. So pressure relief valve, Milwaukee water reservoir, HPLC pump with a gauge. So what I'm going to do is I'm going to pull up some water and put this way. And then turn on the pump. Now I've primed it and water is coming out. Now if I turn it this way, water should continue to come out. Take off this nut. Start it. So what's happening is that this pressure relief valve is keeping it at 4,500 psi. If we want to, we can turn it down. Keep it at 3,000 psi.
Okay.
So it has a range depending on how far in and out you put it. The reason we do this is because if we started this HPLC pump and it was pumping the dead end,
Yeah.
this would spin all the way around and we would destroy our valve.
Yes.
I mean, destroy our pressure gauge, which we have done, we had done numerous times.
Okay.
So this gauge should get you to anywhere that you're allowed to dive with these. Because 5,000 meters should be somewhere in the 40,
Yeah.
74, 7,300 range. You can also, this is just an NPT fitting. You could take this off and get your own with
Another one.
bar.
Oh.
if that made more sense to you.
Yeah.
We deal in PSI,
Mm.
we convert back and forth the bar,
Yeah.
whatever.
Okay.
So this also allows you to just let it sit there.
Mm-hmm.
So if we shut this off now,
Mm-hmm.
we should maintain that pressure.
Okay.
Because you have to pressurize this line before you can open this valve
Mm-hmm.
and figure out what the pressure inside here is.
Okay.
So I'm actually going to turn this. I'm going to turn this back up a little. We tend to keep the pressure high when we do this because when you start draining the bottle,
Mm-hmm.
the pressure is going to drop, and we don't want it to drop where you're going to get two phases
Okay.
when the gas is going to
Yeah.
come out of solution.
Yeah.
So we're just going to stop this for now,
Mm-hmm.
and we're going to put the valve on. Titanium. This valve is titanium, and that is this. This is all titanium.
Mm-hmm.
The ferrule goes on like this. Very important. It will not work if you put it on like that. So the ferrule goes on like that. So to make sure that this is always seated, we just give it a tap. Cool. Close that. All right, this has come down a little bit, but not too much.
Mm-hmm.
So now, once we're happy that there's no leaks, we can open this. And once we open the accumulator, this needle is going to go to whatever the pressure is inside this bottle.
Yes.
Because this is such a small volume, it
Mhm.
doesn't really add anything to the pressure or take anything away from the pressure.
Yeah. Smaller.
I pumped it up on purpose
Yeah.
so that it would register because I knew it was at 3,000.
Yeah.
So read this, 2750-ish. So that's the pressure.
Mm-hmm.
We can just turn this on. We're going to pump this up to higher than it was at, but that's okay.
No.
We're good. So now you would record that bottom pressure. You know it's a good sample.
Mm-hmm.
So now we're going to take a sample.
Okay.
And the reason we have this is so that we can take a sample. Put this on. Before that, what do we have to do?
Have to open the valve.
Scan. Seven's talking. So now, what we're going to need to do, we might need to do quickly. So when I open this, if that nut isn't tight, it's going to leak.
Mm-hmm.
So it's always something you, whenever you hit open, always be ready to hit close. You can
Okay.
go straight to close. You don't
Yeah.
have to go aboard then close.
All right.
Could you just check that that top valve is closed? All right, open. You heard it open. That little bang you heard was all that 4,000 PSI water hitting the bottom of that valve. So no leaks. There's about 4 milliliters of dead space in
Mhm.
here. So you always want to take a bleed.
Yeah.
So take about 2 to 4 milliliters out so that you're getting fresh.
Yes.
Now we're at 4,500. Everything's happy. We can open this very carefully. We can meter how fast, slow, fast,
Mm-hmm.
slow. And notice we're staying at 4,500 psi the whole time I'm sampling this. So if this were gas tight, we could close it. There's be a valve here. We always pull back to make sure we get everything in here. Close the valve,
Mm-hmm.
take it off, and then you've got your gas tight fluid exactly how it is in here and exactly how it comes out of the hydrothermal vent.
Okay.
Once you put this on here, because this is atmospheric,
Yeah.
as soon as it comes out, it depressurizes.
Yeah.
So that's why we pull back.
Okay.
Because what you're going to have is you're going to have a situation where you're going to have fluid
Mm-hmm.
and gas. So you pull back, you close the valve,
Uh-huh.
and then you will have your sample with your gas
Yeah.
and your
Okay,
fluid.
it's headspace.
So if you have 2 mils of fluid,
Yeah.
you have a headspace, however many, whatever is of gas,
Mm.
then you analyze however you wish.
Okay.
You can inject the headspace onto a GC, you can do a purge and trap. Totally up to you what you do with it.
Okay.
And if you wanted to take metals, major cation anions, you just dribble it into a bottle. And you see how the pressure is dropping quickly.
Mm-hmm.
That's why we keep the pressure so high,
Yeah.
so that we can actually fill a bottle and not have to wait for it to come all the way back. Like if we kept it at bottom pressure, it would drop too low. There's no reason you need to keep it at bottom pressure.
Okay.
Higher than bottom pressure is fine. The main thing you care about is a single phase.
Mm-hmm.
So that's how you sample an IGT. So you bring it up, set up your HPLC,
Mm-hmm.
you pump up the line in between, make sure that you have no leaks by turning off the HPLC. Then you open this, the pressure will go to whatever bottom pressure is. So if you were at 1,000 PSI and bottom pressure is at 3,000, it would have jumped. And we were at 4,500, but bottom pressure was 3,000, so it fell. You're getting feedback here at 200 milliamps
Yeah.
that says that the motor is turning.
Yes.
But it's great to have visual confirmation
That's right.
that the coupling is actually turning, because there are times when this may get loose.
Okay.
And the motor may be turning, but the coupling may not be. So you want to see this
Just turn.
turning. That's why that screw is a little bit long.
Okay.
So you just ask the RV pilots to see if they can see that. And it's just visual confirmation that you're opening.
Mm-hmm.
It's just a little mental checklist to help you ensure that you get a good sample.